In this video, we will practice some examples on annuities. Example 1. Calculate the present value of an annuity immediate with annual payment of $3,500 made for 7 years if the interest rate is 6% per year. So I will start by drawing my timeline. There are 7 years involved here. 1, 0, 1, 2, 3, 4, 5, 6. Payment, it's an annuity immediate, so payments are going to be made at the end of the period. And the payments are 3,500 at the end of each year. So 3,500, 3,500. Great. Interest here is 6%. So to know the present value, I will use the formula, which is giving us 1 minus 1 plus I to the power minus n all over I. You can reference this in our previous video on annuity immediate and annuity due. All this times P, which is the level amounts being paid. P is equal to, in this question, 3,500. I is equal to 6%. N is equal to 7. So fixing these variables back here, I'm going to bring my P to the front here. Oh, let me just keep it at this. 1 minus 1 plus I is 1.06 to the power minus n, which is 7, all over I, 0.06, times P, which is 3,500. So I put everything that is in the brackets on my calculator. I have 1 minus 1.06 to the power minus 7, all over 0.06. And it's giving me 5.5824 times 3,500. So if I multiply this by 3,500, I'm getting 19538.34. So this is the present value of 3,000 made at the end of each year for 7 years at an interest rate of 6%. Question 2. What is the future value of an annuity immediate with yearly payments of $2,000 invested for 8 years at an annual interest rate of 4%? I would like to put all this information on my time diagram. There are 8 years involved here. So 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Annuity immediate. So payment is being made at the end of the period and it's being paid yearly. So these are years. And the payment is $2,000. So we'll be having a payment of $2,000 at the end of each year. Interest rates involved here is 4%. So what is our future value? Our future value, according to the formula we saw previously, is 1 plus I to the power n minus 1. It's already over. All over I here. 1 plus I all to the power n minus 1 over I. Now, all here, all of this times P. Okay. Now, what is my P? My P is my level payment, which is 2,000 in this question. I is 4%. N is 8 because we have 8 years we are dealing with. So fixing these values in the formula, we have 1 plus I is 1.04. All over, first of all, raise to the power n, which is 8, minus 1, all over I, which is 0.04, times P, which is 2,000. So if I put this side in my calculator, I have 1.04 to the power 8 minus 1 all over 0.04. And that's giving me 9.2142 times here, 2,000. So I multiply this by 2,000, and that is giving me 18,428.45. So the future value of paying 2,000 at the end of every year for the next 8 years is 18,428. So if you deposit 2,000 every year into a fund, by the time you reach year 8, this will be the total value of the fund, given that the interest involved is 4%. Example 3. A company has agreed to lease equipment for a project and needs to pay 12,000 annually, with each payment made at the beginning of the year. If the agreement lasts for 4 years and the annual interest rate is 8%, calculate the present value of these lease payments. So once again, we start by identifying putting the data on the timeline, and then we identify the variables based on what the formula is requiring us to identify. So first of all, I'm going to draw my timeline. There are 4 years involved. So 0, 1, 2, 3, 4. These are years. Payment is being made at the beginning of each year. So 12,000 is being paid annually, which means 12,000 is paid at the beginning of year 1. 12,000 is paid at the beginning of year 2. At the beginning of year 3, same. And then at the beginning of year 4, 12,000. The interest involved here is 8%. We want to find the present value of these lease payments. So the present value under annuity due is, from our previous class, 1 plus I times the present value under annuity immediate. So I would say present value of due is equal to 1 plus I times the present value of immediate. So here we have 1 plus I times P 1 minus 1 plus I to the power minus N all over I. All of this is the present value of annuity immediate. So what is my P? P is 12,000. I is 8%. N is 4. So if I should fix this in, I have here 1 plus I is 1.08 times P, which is 12,000, times 1, open brackets, 1 minus 1 plus I, which is 1.08 to the power minus N is minus 4 in this case, all over 0.08. So at this point, what I'll do is, first of all, I'll solve what is in the bracket. 1 minus 1.08 to the power minus 4 all over 0.08. And this is giving me 3.3121 times 12,000 times 1.08. So finally, I have 3.3121 times 12,000 times 1.08, and that is giving me 42,925.164. So this is the present value. The present value of paying $12,000 every year at the beginning of the year for 4 years at an interest rate of 8% is 42,925.164. Now, our final question. A facilities manager deposits 5,000 at the beginning of each year into a maintenance reserve fund. If the fund earns interest at an annual rate of 6%, Determine the amount accumulated in the reserve fund at the end of 5 years. So we can see here some keywords. Amount accumulated in the fund at the end of 5 years. So we are looking at future value. And we are saying that the manager deposits 5,000 at the beginning of each year. So we are looking at annuity due. So I'll start by drawing my timeline. There are 5 years involved. So 0, 1, 2, 3, 4, 5. He makes deposits of 5,000 at the beginning of each year. So 5,000 at the beginning of year 1, 5,000 at the beginning of year 2, 5,000 at the beginning of year 3, and so on. And then 5,000 at the beginning of year 5. Interest involved here is 6%. You want to know the future value of this annuity due, and that's equal to the future value of annuity immediate times 1 plus I. So this is giving us future value of annuity immediate is 1 plus I to the power n minus 1 all over I times P, which is the level payments being made, times 1 plus I coming from here. So what is my P? P is 5,000. I is 6%. N is 5. So I can fix this in. Here I have here P being 5,000, 1.06 to the power 5 minus 1 all over 0.06 times 1.06, okay? So what you do is that you fix all of these in your calculator, and then you strive to get the final answer. So here, what is in bracket is giving me 1.06 to the power 5 minus 1 all over 0.06. And that is 5.6371. I'm going to bring this down 5,000 times, and then times, I'll bring this down 1.06. So this times this times this. And that is giving me finally 29,876.60. So the accumulated amount in the reserve fund at the end of 5 years for an amount of 5,000 being deposited at the beginning of each year is 29,876.60. Thank you.